Welcome to another episode of Your Brain Explained, the show which lets you know what's going on in your brain flow. These are getting ridiculous. Today I'm going to be chatting to you about one of my favourite topics, which is how we form memories. First of all, I want to take you back. Imagine you are one of your ancestors thousands and thousands of years ago, living in a very untouched world. You're sent out to go and get food for the rest of your village, and you spot some juicy red berries on a bush which you've never seen before. You collect some to take back, but on your way you're starving, so you decide to have a few to power the rest of your journey. But on your walk home, your stomach starts to feel a little bit funny and you are violently ill. You abandon the rest of the berries, and on your return to the village, you warn all your neighbours to steer clear of them. You describe the features of the bush, what the berries look like and their exact location. It's thanks to your memory that generations of villagers can warn their offspring to stay away from these poisonous fruit. Memories are one of the most important tools in the human shed. They can be advisors for future events, as we can think about how similar situations played out in the past, but also they can be our foes in moving forward if we are mentally stuck in the past. Your brain is the keeper of the memory keys and stores thousands of your most precious and would rather forget moments. Your brain also decides which of your memories are most important, and those which don't make the cut are tossed into the permanently deleted bin. Physically, a memory is a number of connections between cells in different brain regions. These connections are strengthened during memory formation, and the more this memory is used or deemed important, the more likely it will be to stick around in your head. Non-events like what you had for dinner last Monday are easily forgotten, unless last Monday was your birthday and I'm sure your dinner was very nice and very memorable. Memories are pretty much an alteration to your brain's wirings, so grab your pliers and let's get to grips with what memories actually are. We have two main types of memory, our short-term memory and our long-term memory. We think of short-term memory as being recent events, but in your brain, short-term memory is information which is stored for 30 seconds or less. The difference between your long-term and short-term memory in the brain are the regions which are activated during these processes. Short-term memory engages the prefrontal cortex in the frontal lobe, and this contains regions which are key to your attention. Your short-term memory uses your immediate attention to hold on to information. This could be like when you're trying to remember that ridiculously long Wi-Fi code stored on the back of the router to enter into your computer. You keep these digits and letters in your head just long enough to type them out, but you would find it very difficult to recall them even 30 seconds later. This is because your attention centres have disengaged and dropped the code from your brain. When it comes to our long-term memories, there are several different categories. We have our muscle memory or procedural memory, and this stems from our cerebellum. What muscle memory allows you to do is to remember skills such as hitting a tennis ball or playing the piano. We also have our declarative memory, and this is what allows you to recall experiences you've had in the past. This includes our semantic memory, which is learning facts such as London is the capital of England, and episodic memory, which describes past events and individuals that we know. Declarative memory is centered in the temporal lobe in a specific region called the hippocampus. And this is where long-term memory formation is initiated. The hippocampus was found to be crucial to long-term memory formation in a specific patient who had his removed. This patient was called patient HM, and he suffered from severe epilepsy. The root of his seizures in the brain was in the temporal lobe, specifically around the hippocampus. Doctors decided to remove this part of his brain to help with his condition, and following his operation, patient HM had no more seizures. However, patient HM could no longer make any new memories, but could only hold on to new information for about 30 seconds. This case study shows us the consequence of not having a functioning hippocampus, and also tells us how crucial this region is to memory formation. Formation of a long-term memory requires creating or strengthening connections between neurons all involved in the experience. You can think of a memory as associations between different senses and feelings. Like when you smell a perfume which one of your friends from many years ago used to wear. You're almost taken back to being with that person and remembering experiences that the two of you shared together. The neurons responsible for bringing together all the aspects of a memory are in different brain regions. So these could be regions like the scent region or the taste region, and regions involved with recognizing people and emotions. And memory is therefore a trace or an engram which connects neurons in different brain regions. And when one association is triggered, the rest of these neurons are very easily activated, and that's what gives you that wave of nostalgia. The way neurons strengthen these connections is at their synapses. Synapses are the junctions between two neurons. These synapses can be made stronger by ensuring that when one neuron sends a signal, the other one is definitely going to pick it up and pass it on. One of the ways that synapses are strengthened is through continuous use of a synapse. This is because your brain recognises this connection is important, so it wants to make it easier to ensure that signals are always passed on there. The way neurons pass on signals at synapses is to release chemicals from the sending neuron, which act as keys on receptors of the receiving neuron. These receptors then act as gates and open up, and the signal is then passed through to this new neuron. In memory formation, the brain triggers increased firing between neurons involved in the experience. And this increased use of the synapse tells the receiving neuron that this connection is very important. The receiving neuron therefore inserts more gates or receptors into the synaptic membrane. You can learn all about how neurons signal in my previous video, but very briefly, the way a neuron signals is by positive ions moving into the cell. And at synapses, this movement of ions is mediated by gates. This means that when a signal comes along, there are more gates in the receiving neuron synapse, which means more openings for more ions to flow into. This creates a large signal in the receiving neuron's dendrite, which is then passed along to the cell body and processed as an action potential, which are the signals that neurons use to communicate. This whole process of strengthening synapses, which are frequently used, is called long-term potentiation, or LTP. And if a synapse is hardly used or used less frequently over time, this triggers the neuron to initiate long-term depression, or LTD. And what LTD does is it actually removes some of these gates from the receiving neuron synapse. So this means when a signal comes along, it's less likely to be passed on because this connection is no longer deemed important. During the initiation and formation of a new memory, the hippocampus acts like a trainer for the memory trace. And this is much like when you first go swimming and you wear armbands. The hippocampus activates the memory trace to strengthen the connections between neurons, allowing them to practice their strokes without the consequence of sinking. As time goes on, this trace becomes more solid because of the LTP between the synapses of the neurons involved. After a few months to a year, the hippocampus is no longer needed to activate this trace. This is because of the strengthened connections between these neurons, meaning if you receive one stimulus which was involved in that initial experience, the whole trace will be triggered. And this is very much like you taking off your armbands and being able to swim confidently. So therefore, over time, these memories move from temporal regions to more frontal regions. So with patient HM, he could remember events up to a year before his operation because recalling these long-term memories did not require activation of the hippocampus. So your memories are basically routes through your brain with strong connections between neurons, allowing many aspects of an experience to be pulled together. However, these traces are not completely permanent, and that is because of the mechanisms of LTP, so adding in receptors, but also LTD, so taking away receptors and weakening those synaptic connections. Now we know about how memories are formed in the brain, some of my future videos will discuss if we can improve our memory, why some things are easier to remember than others, like that really annoying pop song from like 10 years ago, which you still know every single lyric to, like why does that happen? And about the processes and diseases which can lead to memory loss. Thank you very much for tuning in to this video. I hope you've learned something new. If you're enjoying the content, please subscribe to the channel. And if you have any questions, catch me over on my social media or in the comments. It takes months or years to create a long-term memory. So this is a message for all you people who have tests coming up. Start working now.